Hello, my name is Beth Dixon, and this is a video series based on Vicki Borlaug's PowerPoint presentation on the confidence interval on the mean. For this video on this PowerPoint, we are working with X being normally distributed with the population standard deviation, or sigma, as a known value, and approximations for large sample size n greater than 30. I wish to thank Mrs. Borlaug for allowing me to use her PowerPoint to make this set of video, and this is part 4 of the video series. In this part, in the previous parts, we have covered an example and on how to find our z sub alpha scores. Now we're ready to look at example number 2, and these are for large sample size n greater than 30. The central limit theorem tells us that for large sample sizes where n is greater than 30, the sample means are approximately normal. And also for large sample size, again for n greater than 30, the sample standard deviation, S, gives a reasonable approximation for sigma. And we will use this information in the next example. Example 2, 40 adult rabbits of a certain breed are randomly selected and their weights in pounds are recorded. Construct a 99% confidence interval on the mean weights of the adult female rabbits, and we have the 40 rabbits listed here. So we want to find the sample size, sample mean, and the sample standard deviation on the TI-84. And you will put the data in L1 and do 1var stats. I am not going to go through that in detail. I will arrow back to this screen so that you can pause here and take the time to do that yourself, but you will put those data, these numbers listed in the box here, in list 1. Once those numbers are in list 1, you will choose stat, then over to calculate and 1var statistics, and calculate the one variable statistics that are listed here. You will get a sample mean of 8.7675, a sample standard deviation of 0.6277, and our sample size of 40. If you need help doing this, I do have previous videos on that subject. So there is our important information. We do have a large sample size because our n is greater than 30. The central limit theorem tells us that the sample means are approximately normal for large sample sizes. And also for large sample sizes, the population standard deviation, sigma, can be reasonably approximated for sample standard deviations of S. So we'll approximate our population standard deviation by saying that's 0.6277 for sigma. And we want to construct a 99% confidence interval on the mean weight. So we want to write down our formulas to start out with. E equals z sub alpha divided by 2 times sigma divided by the square root of n, and x bar plus e and x bar minus e. First, we need to find the z alpha divided by 2. Our alpha is the amount that we're willing to risk. If we are 99% confident, that leaves 1%, or 0.01. since we're needing alpha divided by 2 because confidence intervals are always two-tailed, that is alpha divided by 2 or 0.01 divided by 2, which is 0.005. Looking that up in the table gives us that we need to find z sub 0.005, leaves us the area to the left of 0.995. 1 minus 0.005 leaves us 0.995 as the area to the left. Looking that value up in the table gives us 2.575. And it gives us that exact value in the table. If you use your calculator and rounded it to 2 decimal places, you would get 2.58. That is why we want to check in our table, and we'll see that little star that tells us to use 2.575. So we have a z value of 2.575. A sigma that we will use S as a good approximation for of 0.6277 and N as 40, so that's divided by the square root of 40. Put that in your calculator and we get 0.2556. Take our sample mean of 8.7675 and add and subtract 0.2556, and that gives us 9.0231 or approximately 9.02, and 8.5119, which is approximately 8.51. So we can say with 99% confidence that the mean weight of female rabbits in this breed is between 8.51 and 9.02 pounds. Again, please follow your teacher's rounding rules. In this case, I think Ms. Borlaug is going to use to round to one more decimal place than your original data. As a summary, or just to say, using the z distribution to find a confidence interval requires us to use S for sigma. In a future section, if the x values are normally distributed, we will learn how to use the t distribution, and this does not require us to use S for sigma. And then before I go on, I want to go back to our sentence here. I feel real bad because I went through it the first time I introduced the sentence. I was supposed to say some more about it. I said some more about it at the end of the last video, but let me reiterate one more time about the sentence. For Miss Borlaug's class and a lot of classes, your sentence will be, the structure will be the same every time. In this case, the 99%, the percent changes with the problem, and that percentage is given to you in the wording of the original problem. But the I can say with confidence stays the same. That, the, and then just look at your problem. In this case, we're talking about the mean weight of female rabbits. That again is from the problem. So that part varies problem to problem, or the mean weight of female rabbits in this breed, and then is between, and then you fill in your lower confidence limit and your upper confidence limit, and then in whatever unit you're measuring them in, whatever it may be. The last problem, it was centimeters. In this case, it's pounds. So then you put that unit as the last word, and that gives you your sentence that you will need to fill out. Here is a class question for you to try. And here are the upper and lower class limits, remember your answer does need to be in the form of a sentence and you will need to show your work for full credit. This is a good place to pause and end, and I will pick up the next video with the last part, and I hope this was helpful. Thank you.